Hello YouTube, De-bodgery here. So this is an ASI controller without its brain pan, which is all this little daughter board really is. You know, it's the MCU, a couple little support chips, and a Bluetooth module, some DC to DCs. That's it. Otherwise, everything else is right here. It would have been super cool if ASI wasn't married to TI. And instead used an STM32, because if that was the case, then I can pretty much guarantee you that somebody out there would be trying to port this thing over to run VESC. But because it's not an STM32, it's a TI chip, you know, whatever it is, a TP320, that's not going to happen. But it would be super cool if you were running VESC on an ASI BAC8000. Anyway, it's still FOC, which is very good. Can't complain about that even slightly, because quite frankly that is an important improvement in motor control that frankly everybody should be doing. And considering how inexpensive it is nowadays to have FOC support in a motor controller, why people aren't doing it is a complete mystery to me, other than they don't like the extra complexity of setup that it creates. Okay, great, that's fine, but it doesn't have to be that hard either, because I can tell you that like nuclear controllers are not that complex to set up, and they are in fact field-oriented control as well. ASI is a more complicated one, but even that, if they would make their software more user-friendly, wouldn't be hard either. So let's talk about this board. Okay, this is going to sound like I've contradicted myself, but it's not. So as you can see, 5 brass standoffs. So several key factors to those standoffs. First of all, they are much larger than the ones on the KO Pro. So just diameter alone, there's more surface area. Second is the solder pad that they're soldered onto. This is a multi-layer board, probably 5 or 6 layers inside there of copper. And these pads, they go through all of those layers, and they're soldered together, and they've got little holes in them. Those are called vias that are soldered as well, and this is soldered down to all of that. So there's much more support here just in diameter, in circuit board traces, all that stuff to make this much stronger. Whereas on the KO Pro, that is a single trace on one side of a metal-backed board. So strength isn't really its strong point anyway. Whereas this has a lot more strength to it. Plus, this also has a center stud, which is also soldered in place. So much more support here, and so much so that ASI was confident that you weren't going to wrench these things out very easily, and used hex head screws everywhere, rather than Phillips head screws that are more likely to cam out than to crank on them too far and possibly twist the brass studs out. So yeah, I have a great deal of confidence that these are going to hold up, you know, even for some Gorilla that might over-tighten on them a little bit. But could you twist these out? Well, sure, solder will eventually break, but this has got so much more strength on it than the KO Pro does that that's probably fairly minimal of a risk. All right, something else that I said about the KO Pro is it has 2 current sensors, and well, look at that, so does ASI. Thing is, though, is I'll bet you about 6 or 7 or 8 or whatever of the KO Pro current sensors cost as much as one of these. These are very high-grade current sensors, and ASI only needs 2 of them. Whereas, you know, KO, they've got the cheapest possible ones you can have, and they also use 2. So I would say that this is completely acceptable, and quite frankly, 2 current sensors versus 3 is a somewhat common thing. So I'm not really overly concerned about that. This isn't a cost-cutting measure. This was simply they didn't need a 3rd one. Whereas KO, they're already cheap and they're already cutting corners every chance they get. So yeah, they didn't have one just because it was money they could save on manufacturing costs. Whereas ASI did not cut corners. They used very expensive current sensors. And they also use Nichicon capacitors. These are very good capacitors, very low ESR capacitors, very reliable, high, long lifespan capacitors. These are all 220 microfarad, and there's 19 of them. Nichicon, good brand. Awesome to see that. I knew these were in here before I ever even cracked the case. because ASI doesn't skimp on quality. And I'll talk about that some more too when I get to the MOSFETs. Anyway, yeah, this is all a very good design. I don't really have a lot to say here that's negative. You can see on the board here, so there's several little ceramic caps, and those are on all the phases for high frequency ripple filtering. And each one of the phases has got a bunch of those little ceramic caps. I think I said they were tantalums on the KO. Yeah, I make mistakes from time to time. What can I tell you? Each one of the phases has two little 6-pin chips on there, and that's your high side and low side gate drivers. And I believe that guy right there, I haven't looked up its part number to be sure, but I'm pretty sure that's like some kind of a demultiplexer sort of a device that's actually doing the gate driver control. I'm pretty sure that's what that guy does. Alright, so is there something else I want to show in here? I think that's it. Yep, that's it. Let's flip this bad boy over and look at MOSFETs. Alright, so the first thing I want you to notice is there is no copper reinforcing. That sounds like a contradiction, doesn't it? After I went on and on and on about the shoddy quality of copper reinforcing in the KO Pro, here I am looking at a BAC8000 and there is no copper reinforcing. Ah, but there is. You just can't see it. But I can. Okay, so let me explain what these solder pads are. So that's a phase, that's battery minus, that's a phase, that's battery plus, and that's a phase. Okay, so first of all, there is a rectangle of circuit trace right here, just standard thickness stuff, nothing particularly special, but it's that big. And that's that phase. Then there's another one right there that's also about that big for that phase. And then there's another one right there that's that big for that phase. Plus, keep in mind, this is a multi-layer board. There's like 5 or 6 layers here, and each one's got its own layer of copper in it. So inside the board, there is another layer that is like that, and here, that is reinforcing this layer of copper on here. So while you can't see it, there is actually copper reinforcing here. It's just inside. Also, this is battery minus. There is a sheet of copper inside here that is literally everything here. That is the battery minus. And then there's another one on another layer, same thing, full size there, that's battery plus. And then through all of the through holes, the vias that are in here, all of those traces and layers and stuff are tied together to the MOSFETs and back over to these pads. So while you don't see any copper reinforcing, it's there, it's just inside. So very clever, good job ASI, you did it integrated inside your board and you didn't have to solder anything onto the surface because it's all inside the board. Is the copper reinforcing here? Oh yes, absolutely it is. Is it on the surface and soldered down? Nope, it's inside. So good job on that one ASI, can't bitch about that even slightly because it's a clever design. It made it much simpler. It took a manufacturing step out of the process because nobody had to solder any copper down. It's there already in the manufacturing of the board. So that's not a problem. Okay, I do have an issue, or I guess two, with these controllers. So the first one is repairability is pretty much non-existent. Things that blow up are MOSFETs on controllers. That's almost always what happens. And because of these little brackets and just how impossibly hard they are to get out, at least it was for me, you know, getting them out so you can pull the board away from its heat spreader is probably going to damage things worse. So yeah, repairability is low. And the second bitch I have is the MOSFETs. So these are TO220 MOSFET packages, and specifically they are AOT MOSFETs. And let me look at one real close with my magnifier here because the numbers are tiny. And I can't read that one. Scratched it up pretty good, trying to get it out. There we go. So they are AOT, so T66916 MOSFETs. AOT is a very good brand of MOSFET. Do not have anything to say negative about AOT products. They are very good. About the only thing I could say that I would have liked to seen more is if they use like MagnaChip. But that's it. Otherwise, AOT, there is nothing wrong with that brand of MOSFET at all. They're well known, they're well liked. Yeah, nobody has any bitches seriously about AOT products. because, you know, you can trust them to be highly consistent, highly reliable, high-grade components. Okay. However, with the TO220 package specifically, that has nothing to do with AOT because 1,000 people make TO220 MOSFETs. The leg is two parts. It's got a thicker part and a thinner part. The thicker part, and this is just standard TO220 packaging specs, the thicker part is rated for 75 amps and the skinnier part for 50 amps. So if you want best case current handling in a MOSFET or whatever semiconductor you might have in the package, you want to use the thick part of the MOSFET or the package leg. If you want to minimize heating as much as possible, use the thick part of the leg. Whereas ASI, they soldered everything down by the thin part of the leg. Whenever I build something or do controller upgrades, something like that, I always solder to the thick part of the leg because I want the best case scenario heat transfer from the leg into the circuit board, or the least amount of heat creation in the leg I can possibly have, and I want the best possible current carrying capability. And ASI didn't do that. They used the skinny part of the leg. So I wouldn't do that. I would say that's a, not so great thing. I would definitely not do it this way. I would solder the thick part of the leg right to the board so that you have that best case scenario. Anyway, that's my single biggest complaint right there, is how the MOSFET legs are done. And then my second biggest complaint are these things. They make disassembly really hard, if not just damaging everything. In fact, I did. So, like that MOSFET's hanging by a leg, that one's hanging by a leg. You know, their tabs on them are buggered up pretty good. The face of a lot of these MOSFETs are all scratched up from, you know, jamming screwdrivers and pushing and shoving and things like that to finally get these stupid pieces of steel out of there. So, yeah. Repairability is low. So, yeah, if you wanted to fix an ASI controller, you're probably going to make it worse before you make it better, if it works when you're done, because that's also a possibility. In taking the potting off, and I was trying to be really careful. Nevertheless, there was an inductor right here, and I caught my spooger on it, and I snapped her right off. I don't know how I did this one, but there's a little capacitor, a little ceramic cap right down there by that current sensor, and I broke that off too. So yeah, I damaged this board, despite all of my effort to be very, very careful. I damaged it anyway, so yeah, I would have to fix the thing before I could fix the thing. Yeah, ASI didn't want you to fix it. That's just what it is. But yeah, as far as design, level of integration, I don't have any real complaints. Just wish that they had used the fat section on the MOSFET legs. That's the single biggest thing I would change here. But the integration of the copper reinforcing inside the board, good job, ASI. Totally clever. Glad you did that. Yeah, no extra manufacturing cost that way. Just multi-layer board that does it for you. So, no bitches there. Anyway, hope to help some folks out. This has definitely been an interesting teardown. I've wanted to do this to a BAC8000 for, oh, I don't know, 2 years, something like that, ever since I heard about BAC8000s getting released finally. I wanted to take one apart and see what it was like inside, and now I have. By the way, all this stuff over here, this is grunge from me unsoldering the daughter board. That wasn't there. This board was very clean. ASI washed it. There was no flux on here, anything like that. Any residue on here is from the potting, other than this, and that's all from me. That's 100% from me unsoldering this. Well, I think that's it. Hope that helps some folks out. This was fun for me too.